So you may have noticed that we skipped section 2.4.
Oh yeah, I noticed. I was wondering why we did it, and I read it on my own website.
That's good, Nikki. Yeah, we skipped 2.4, and here's why. It's all about, all we're going to talk about today is finding zeros. You know what zeros are? Zeros. Finding zeros. Huh? Yeah, you said x-intercepts, didn't you?
Yeah, X and Y, but...
No, just x-intercepts. Zeros are x-intercepts, or roots. You could call them roots. It's all the same thing. So 2.4 and 2.6 are all about finding roots. They just throw 2.5 in there in the middle of it because you need to know about imaginary numbers. But you already learned that part, so now we'll do this. Well, 2.4 it says Descartes' rule of signs. And this is crazy. Did you learn this, Annie?
I remember.
It's like, basically it's this. If you have a function, you probably don't want to write this down. Don't. I said don't. Here, I'll read it to you. It says, let f of x equal, are you guys on this page? 42. It has this big old thing. You got a polynomial with real coefficients. It says the number of positive real zeros of f is either equal to the number of variations in sign of f of x or less than that number by an even integer. Here's what that means. When it talks about the variations in sign, this is positive, isn't it? And then it switches to negative. That's one variation in sign. And then it switches back to positive. And then it switches back to negative. So we got 1, 2, 3 variations in signs. Right? Dig? The signs changed 3 times. Well, it says the number of positive real zeros is equal to the number of variations in sign of f of x, or less than that number by an even integer. So if we're talking about positive zeros or x-intercepts, there will be either 3 or 1.
What?
That's what that says. And he's right. That is the number of negative real zeros, so the number of negative x-intercepts, like the signs of your x-intercepts. The number of negative intercepts is equal to the number of variations in sign of f of negative x. And then you have to do f of negative x and see how many times the signs change, and that'll give you the number of negative x-intercepts. Whoopity-doo! This might have been useful in 1974, but we don't care now, because we have graphing calculators. This is why I don't want to put this. I don't want people to watch this. Did you learn about this? Did you do this? Yeah, it sucks, huh? It's so bad. And then you have to combine this with the rational zero test. And what the rational zero test is to find the x-intercepts. You take, let's see, you take the, I can't even remember because I haven't done it in so long. Oh yeah.
So why are we doing it now?
I'm just telling you about it.
We have to know this?
Yes.
So we write it down.
No, don't write it down. Let's see. What you do to find the rational zeros, or the rationals with fractions, right? So this will help you find the x-intercepts that are fractions of this. If you take the factors of the back number and divide that by the factors of the front coefficient. So the constant factors of the constant divided by the factors of the coefficient of the leading term. Lots of big math words in there. Basically, what are the factors of 4?
2, 4,
1, 2, and 4, right? So if you do plus or minus 1, plus or minus 2, and plus or minus 4, those are all factors of 4, aren't they? Could be all. And if you divide any of those by the factors of 3, which are just plus or minus 1 or plus or minus 3, among those many, many possibilities, you will have the rational x-intercepts of that function. So 1 could be 1, negative 1 could be 1. You could have 2 or negative 2. You could have 4 or negative 4. You could have 1/3 or negative 1/3, 2/3 or negative 2/3, 4/3 or negative 4/3.
And then you have to like do the thingy with every.
And then you have to do
one of them.
synthetic division with every single one to see which one gives you a remainder of 0, and then you know you finally found one.
Is there an
I don't
easier
like
way?
that.
There is. It's called a graphing calculator. Welcome to 2015. So I'm like, it's cool that this guy figured this out and stuff, like way back, you know, like, good job. Well done. But it's April 29th, and we're only on chapter 2, and so this is a perfect place to kind of just go, okay, cool, dude, well done. Now we're going to move on. Because we don't got time for this. Because it takes a very long time, doesn't it? Oh, and you use this, you go, oh, there could be 3 or 1 positive one. So, you know, then I can use that, and I could use this, and I could sit there, and you could sit there, and you could find the rational zeros only. If they're not rational, you're screwed, because that's not going to help you. Good. Okay. This is just a way to find the x-intercepts. If you take the factors of the back number and divide it by the factors of the front number, you'll find an x-intercept in there somewhere. Like I said, and if you do synthetic division, like let's say, oh, 2/3, that's one of the possible x-intercepts. So if I go 2/3 and then I go 3, -5, 6, -4, do synthetic, 3, 2, -10, -20 thirds. It's going to get hard. -2/3, 4/9. Hey, that's not 0, so that's not an x-intercept. You have to get a remainder of 0. Oh, better try a different one. And look, there's a lot of possibilities there, aren't there? We're not going to do that. I'm going to teach you on a day when everyone's here how to use graphing calculators to do all this stuff.
And sometimes it's better to get the whole numbers. Sometimes the fractions are worse.
Yeah, some fractions are terrible. Usually you start with the whole numbers, but then on a dirty problem, they're not whole numbers. So we're not going to do that. That's all 2.4, is doing all of that lots and lots of times. I mean, like, look at this one. I like this one. Example 4, using the rational zero test. And it gives you this one, with 10 and 12. Here are the possible rational zeros. Look at all that. 1, 2, 3, 4, 6, and 12 divided by 1, 2, 5, 10, or 10. So with 32 possibilities. So you could do synthetic division 26 times and still not find one if you're unlucky. I mean, ain't nobody got time for that. It gives you other way. You can, yeah. But. So there it is. There's 2.4. Yep, that's it.
Yeah, you really recorded that.
Well, now we're going to do 2.6. We're going to get to stuff you do need to know that you do need to write down. I'm just telling you about this stuff and showing you, yeah, it exists. So when you get to pre-calc in college, have fun. Because you'll have to do it. That sucks.
Right? So, pre-cal college. College?
Riley is?
Yeah.
She liking that?
No, she hates math, so I doubt it.
Yeah. That'll make you hate math right there. 2.6 now. Ah, the old fundamental theorem of algebra. Sounds important, right?
No.
The fundamental theorem of algebra. First proved by the famous German mathematician Carl Friedrich Gauss in 1777. Oh, that's when he lived. It wasn't very old. Anyway, it says if f of x is a polynomial of degree n, or n is greater than 0, then f has at least one 0 in the complex number system. Cool. Here's what you need. There's some other stuff. The linear factorization theorem. Here's what you need to know. And I think you already know this. If I give you a function, I don't know, any old function. There's one. How many x-intercepts could that have? 4. Yep, that's right. That's all you need to know.
That's it?
Yeah, basically. Well, he's saying that that has at least one 0 in the complex number system. Okay, well, here you go, watch. This is, here you go, watch this. f of x equals x squared minus 4. Can you find that the fundamental theorem of algebra would say that that has at least one 0 in the complex number system, meaning there's at least one x-intercept that's going to be a complex number, right? Complex numbers are real and imaginaries, right? Well, you know how to find the x-intercepts of that, right? Factor it. x plus 2, x minus 2 equals 0. So x equals 2 and x equals negative 2. Which one is in the complex number system?
Negative 2. 2.
Negative 2 is a real number. 2 is a real number.
Neither.
True question, they both are.
I was gonna say.
Oh, stupid. Alright.
That's the dumbest thing I've ever seen in my life.
If you go on further, you could learn about, like, into really complicated math. But for this class and for calculus, you don't need to know. It's like whoop-de-doo. That has 4, maybe. That has 2. All right. Jeanette leaves right when you get to the stuff that you actually need to know.
She's gonna come back, she's gonna be so confused.
Okay, starting now. You might want to start right. It's more about zeros. So when we do them in this class, like, if I give you one like this, I just broke my pen, so it's going to take a moment. I could give you something like that and say find all the x-intercepts, or find all of the zeros, alright? Well, do you know how to factor that?
Could you do
Nope, it's x to the 5th. You don't. So when you get a problem like this, we could do the rational zero test and do the factors of that, but we're just going to kind of skip that part. So when I give you these, I'm going to cut a bunch of time out, cut a bunch of guess and check on synthetic division, because I think you could do the factors of 8, 1, 2, 4, 8, and you could divide them by the factors of 1, 1. And then you could sit there and guess and check with synthetic division all day. I'm confident in your ability to do that. So I don't need to watch you do it for 30 minutes a day. So I will always either give you one of the zeros, or maybe 2 of them, or I'll let you use a graphing calculator to find 1 or 2 of them. And then once you know that, you can move on. So for example, let's say I give you this, and I say, okay, x equals 1 is a repeated 0, actually. You know what that means when it's repeated? That's like if you have, let's say you had x, why is my pen being dumb? Let's say you had x squared plus 4x plus 4. When you factor that, that's x plus 2 times x plus 2, right? So x equals negative 2 is a repeated 0. Because there's 2, it's almost like it's there twice, right? Graphically, it bounces off of that point, but just it's a repeated 0. So when I say x equals 1 is a repeated 0, means if you factored this all out, you would have x minus 1, x minus 1, and then some other stuff. Right? So how do you get the rest of the zeros? 2 ways. Well,
I'm like in the middle of teaching.
yes. Okay, I'll play that. How can we get the rest? What do you say? I can't hear you. Speak up, you might be right. Synthetic division. Yeah. We know that. So if we do synthetic division by 1, that'll break it down to x to the 4th. And then we'll do it by 1 again, that'll break it down to x to the 3rd. Then maybe we can do some grouping or factoring, of some kind to break it down a little more. So we could do synthetic division twice. Or you could take that, multiply it together, that'd be x squared minus 2x plus 1. Or you could do long division once. Doesn't matter. Isn't this the same as this?
Yeah.
It's So if I divide this by this with long division,
With synthetic division, you just do 1.
yeah, you would just do 1. You could do synthetic, 1, and then 1. There's no x to the 4th. 1, 2, negative 12, 8.
Drop the 1.
Yeah, we could do this. Drop the 1, 1, 1, 1.
2.
Isn't it 0 minus 1?
No, you add synthetic. 2, 2, 4, 4, negative 8, negative 8, 0. Perfect.
And then you plug those into another one, right?
But wait, don't we know that 1 is repeated? So I should be able to do 1 again.
Yeah, that's
Like
okay.
do synthetic division by 1 again. So rather than rewriting it, let's just go. Is that confusing? Now I'm just using these, and I'll do it again. 1, 1, 2, 2, 4, 4, 8, 8, 0.
And change it. You change it twice then?
Yeah. So if this was x to the 5th,
X to the third.
these answers would be x. This would start with x to the 4th. So this is x to the 3rd plus 2x squared plus 4x plus 8. That's what I'm down to. So what I was saying is, you could do this synthetic division twice, which is probably the easiest for most people. Or you could have taken this, and if you would have divided that by that with long division, you'd go straight to that one time. Who likes long division? Ruben, yeah, good boy. He likes it. Think we could factor that? Group them? Yeah. So now you can get the rest of the zeros. That's it. Group it. So you'd have x squared times x plus 2 plus 4 times x plus 2.
And then X squared equals
So it's x squared plus 4 times x plus 2.
X plus 2.
X plus 2, x minus 2.
No! That's the only difference of 2 squares. It's not negative.
X plus 2, X plus 2.
Nope. That would be x squared plus 4x plus 4.
X minus 2x minus.
When you've got it factored, what do you do with each one of those?
But you can't do square root of negative.
Oh, really?
Maybe you can.
X squared plus 4 equals 0. Subtract 4. X squared equals negative 4. Square root both sides. X will equal, since I'm doing the square root, it'll be plus or minus. What's the square root of negative 4? 2i.
I don't know how to do that.
Uh-oh, you have a quiz on Friday about that. So x plus 2 equals 0, subtract 2, negative 2. So now you have all of your x-intercepts. Alright, you got 1, 1, negative 2, and then I'll write them all out. 2i and negative 2i. Those are your 5 x-intercepts. So could you write that in factored form?
X minus 1, x minus 1, x plus 2, x.
Yes. I was just saying, could you write that out in complete factored form? Yeah, it'd be x minus 1 times x minus 1 times x plus 2 times,
X minus 2. Just kidding.
just write x squared plus 4.
Oh, okay.
That's good. You could do, or if you wanted to be, you could go x plus 2i, x minus 2i. So I guess that is the factored form of that. So that would be the more proper, official, completely factored answer.
So why didn't we do the difference of 2 squares?
Because it's not difference of 2 squares, it's addition of 2 squares.
So it has to be a
It
negative.
has to be a negative. more thing. One more problem like that. So here's one. F of x equals x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60. And I tell you that x equals 1 plus 3I is one of the zeros. Well, there's something special that happens with complex numbers and zeros of polynomials. Do you remember, Andy? No? If 1 plus 3i is one of the zeros, you know what else is one of the zeros? 1 minus 3i. They always occur, your book calls it, they always occur in conjugate pairs. Hey, that word conjugate, right? They always occur in pairs. You're never just going to have 1 plus 3i as one of the zeros. It's not possible. It'll always have 1 minus 3i. So if one of the, just like we had over here, we had 2i and negative 2i. That'll always happen. If you've got one complex number, you'll always have the conjugate pair of it for another one. So if I tell you x equals 1 plus 3i is a 0, you can't do synthetic division with a complex number.
Long division.
You can't do long division with a complex number. Because how are you going to divide by I? It's not going to happen. But you do know that 1 minus 3i is another one, right? Because I just said they occur in conjugate pairs. Yeah. We know that, right? So we got two of them. So could you write the... I'm just looking at the clock.
I can see that.
Yeah.
You wanna wait for tomorrow?
I think I want to wait till tomorrow. I don't think I want to rush through this in 8 minutes.
I'm okay with that.
Sounds good.
Possibly.